Hello and welcome to Eternity Tutorials. In this video I'll be dealing with algebraic identities. Let us see the first identity. It is x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. This you will get the result by opening these two binomials. As we multiply these two, the LHS, we get the RHS. Let us take one of the examples based on it. Let's see x plus 4, x plus 10. So here a is 4 and b is 10. So when you open these brackets, you get x square plus 4 plus 10 into x plus 10 into 4. This is equal to x square plus 14x plus 40. This is almost the reverse of the middle term splitting that we do. Next, let's see the next identity. A plus b whole square is equal to a square plus b square plus 2ab, and for minus we have a square plus b square minus 2ab. Now if you have the question 9x square plus 6xy plus y square, we know that 9x square can be written as 3x whole square and y square can be written as y whole square, and this can be written as 2 into 3x into y. Please see, wherever you have xy, this term, this will be equivalent to 2ab always. And if you compare these two, you get a square plus b square plus 2ab, which makes it 3x plus y whole square. Now the next identity is a plus b plus c whole square, which is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now the question is x plus 2y plus 4z whole square. If I apply the above identity, I get x square plus 2y square plus 4z square plus 2 into x into 2y plus 2 into 2y into 4z plus 2 into 4z into x. Now this becomes x square plus 4y square plus 16z square plus 4xy plus 16yz plus 8xz. Let us take another example. This example is the reverse of the above question. If I have 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now if you see, there are two minus here. That means there is one term, either b or c, which has minus sign in front of it. So let us see. If you see this term, it has y into z. So either y term or the z term, either of them has minus sign. And if you see the last one, you get x and z. The common out of these two is z, which shows that z has the minus sign. So that means I can write it as 2x whole square plus 3y whole square Because we just concluded that z has the minus sign, so 16z square can be written as minus 4z whole square plus 2 into 2x into 3y minus, or rather you can write down 2 into 3y into minus 4z plus 2 into 2x into minus 4z. Now if you see, this is a plus b plus c whole square. So we get 2x plus 3y minus 4z whole square. Now the identity is related to cubes. Let's see. A plus b whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. Now this can also be written as a cube plus b cube plus 3ab a plus b. Next we have a minus b whole cube, and we get a cube minus b cube minus 3a square b plus 3ab square. This can be written as a cube minus b cube minus 3ab a minus b. Next we have a cube plus b cube. This is a plus b into a square plus b square minus ab, and a cube minus b cube, this is written as a minus b, a square plus b square plus ab. Now these are the identities related to the cube. Let's see how the questions use these identities. I have the question 2x plus 1 whole cube. I use the first identity and we get 2x cube plus 1 cube plus 3 into 2x square into 1 plus 3 into 1 square into 2x, and which is equal to 8x cube plus 1 plus 12x square plus 6x. Let us take another example. I have 8a cube plus b cube plus 12a square b plus 6ab square. Now this is the reverse of the above question. I can write it as 2a whole cube plus b cube plus 3 into 2a square into b plus 3 into 2a into b whole square. So if you see, this becomes 2a plus b whole cube. Let us take another example. Now 27y cube plus 125z cube. If you see, I can write it as 3y whole cube plus 5z whole cube. This is a cube plus b cube, which can be written as 3y plus 5z into 9y square plus 25z square minus 3 into 5 becomes 15yz. So these are the cube formulas. After this comes a very important formula. X cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now the question based on it, that we factorize 27x cube plus y cube plus z cube minus 9xyz. If you see this, I can write it as 3x whole cube plus y whole cube plus z whole cube minus 3 into 3x into y into z. Now this can be factorized as 3x plus y plus z into 9x square plus y square plus z square minus 3xy minus yz minus 3xz. Now following this, there is an important rule that if I say x plus y plus z is equal to 0, then in the above identity, here this can be written as 0 into x square plus y square plus z square minus xy minus yz minus zx, which becomes equal to 0. Or it implies that x cube plus y cube plus z cube is equal to 3xyz. So we have another rule that if x plus y plus z is equal to 0, then 3x cube plus y cube plus z cube is equal to 3xyz. Let us see how we'll be using it. So we'll take an example. I take minus 12 cube plus 7 cube plus 5 cube. We need to find the value of this, although by finding the cubes of each term and then adding could be complicated. So we take an easier way with the help of this identity. We know that minus 12 plus 7 plus 5 comes out to be 0. That means x plus y plus z is 0. If I say that x is equal to minus 12, y is equal to 7 and z is equal to 5, then from here I know that x plus y plus z is 0. So this minus 12 cube plus 7 cube plus 5 cube, this is equal to 3 times minus 12 into 7 into 5. And as you multiply, you get the answer as minus 1260. Let's take another question, which is 28 whole cube plus minus 15 cube plus minus 13 cube. So now here if we add them, 28 plus minus 15 plus minus 13, you get 28 minus 15 minus 13 is equal to 0. And the cube, that is 28 whole cube plus minus 15 whole cube plus minus 13 cube is equal to 3 times 28 into minus 15 into minus 13. As you multiply them, you will get 16380. So that's the application of this form, this identity. Have an expression, or let's say a question which says factorize 25a square minus 35a plus 12. Now how do we factorize this? Our very first step should be that I write the first term as it is. This minus sign as it is. I put the brackets and I write down the coefficient a here plus 12. Please see, I have written everything as it is, but I have not written 35. Instead of 35, I have put a bracket. Now in between the brackets, I see the sign here, which is plus. The sign in front of the in front of the constant. This is plus. And the sign in front of the coefficient of a square or x square, it is again plus. And plus into plus becomes plus, so we put plus here. Now, what does the middle term splitting says? It says that we need to find out two numbers whose product is 25 into 12. Let us say the two numbers are x and y. So x into y is 25 into 12 and x plus y is equal to 35. We need such two numbers. How do you get it? Please remember, never ever multiply 25 and 12. I take the factorization of 25, it is 5 into 5, and of 12 it is 3 into 2 into 2. I will now do the grouping. Please see, 5 into 13 into 2. Sorry, 5 into 3 into 2, which becomes 30, and 5 into 10 becomes, 5 into 2 becomes 10. So 30 and 10, their sum is 40, which is not valid. I make another grouping. I take 5 into 3, 15, and this 5 and the remaining, these two, into 4 becomes 20, which gives me the sum as 35. So I write down 20 and 15. So we write down 25a square minus 20a minus 15a plus 12. I take 5a common and I am left with 5a minus 4. I take minus 3 common and I am left with 5a minus 4. Remember that these two brackets should be same, and if they are not same, that means you've done something wrong. You need to check. Now in this expression you can see that 5a minus 4 is coming out to be common. So what is left? I am left with 5a minus 3. Let us take another example to make things more clear. So now I have factorized 35y square plus 13y minus 12. So my first step, I write down 35y square plus as it is. I put the bracket, I put y minus 12. Please see the sign here in front of the constant is minus and it is plus. Plus into minus makes it minus. So this time I need two numbers x, y whose product is 35 into 12, but their difference is 13. Now let us see the factorization of 35. It is 5 into 7 and of 12 is 3 into 2 into 2. Let us do the grouping. You get 7 into 3, 21, 21 and 5 into 4, 20. 20 and 21 when subtracted does not give you 13. Let's see again. 3 into 2, 6. 6 into 5, 30. And 7 into 2, 14. If you see 30 and 14 again will not give me 13. Let us take another grouping. 7 into, I take this 7 and I take this 4. 7 into 4 is 28 and 5 into 3 is 15, which gives me 13. So 28 and 15. Now I open the brackets, I get 35y square plus 28y minus 15y minus 12. I take 7y common and I get 5y plus 4, and here I take 3 common, minus 3 common, and I get 5y plus 4. If you see, 5y plus 4 is common and I am left with 7y minus 3, which is the factorization of the expression given. Now usually the questions that you get is to factorize a given expression. But when you get so many questions, then it becomes difficult at times for the students to identify that how do you have to factorize it, by using an identity or by middle term splitting. So there are few steps. Number 1, take common. An expression is given to you. Then find out if there is something common in that expression and we take that term common. Next, we apply identity. If any identity is applicable, then we apply that. And if nothing is applicable, then we apply middle term splitting. So these are the fixed steps that you have to follow for factorization of an expression. So that's all from the algebraic identities. If you have any doubts, please leave the question in the comment section. And if you like the video, please share and subscribe the channel. Thank you.